just says factor the trinomial. We've got b squared plus 11b plus 30. And we want to factor that. First of all, it's a trinomial. It's got 3 terms. When your trinomial starts off with just a 1 as the leading coefficient, that's what I like to call the good or the short kind of trinomials, because there's only one way to get v squared, v times v. So then the last part, that what's going to go at the end of those 2 factors has to do 2 things, right? It has to multiply to equal 30. So 30 times 1, 15 times 2, 10 times 3, and 6 times 5. Lots of ways to multiply to get 30. What does the pair also have to do? Add to the middle number. Which one of these pairs adds to 11? 6 and 5. Both need to be positive, right? If I'm going to multiply to get positive 30 and use those same numbers to add to get positive 11, I need a positive 6 and a positive 5. It doesn't matter where the plus 6 and plus 5 go, since they're both positive anyway. All right, number 2. V squared minus 15v plus 50. Right, another trinomial, but luckily again, it just starts off with a v squared, not a number in front of v squared, which is good. There's only one way to get v squared, v and v. The last numbers have to do 2 things. Multiply to give me 50. Lots of ways to do that. 50 and 1. Yep. 25 and 2. No 3, no 4, no 5. 10 and 5. Is that it? I think that's all the ways to multiply to get 50. Now, be careful with your signs. What are these? So I'm going to use the pair that also adds to negative 15. 10 and 5. So yes, you're going to use the 10 and 5 pair. Because by looking at these numbers, I'm not going to be able to use a 50 and a 1, no matter what you do with your signs, and get a negative 15. I can't do that with 25 and 2 also. So the easier part is picking out the pair. Now I got to figure out what my signs are going to be. Now don't forget, you still have to multiply to equal a positive. How do you multiply to equal a positive? What 2 ways? Either positive times positive. What's the other way you can multiply to equal a positive answer? Good. Won't that also multiply to equal a positive? So that's not going to mess that up. So let's look at that. Won't those, if you add those together, won't that give you the negative 15 that you need? Yeah. So now, it doesn't matter where you put them. It just matters, what matters is the signs that go with the numbers. So as long as since they're both negative, just do a negative 10 and a negative 5, either way. Number 3, a squared minus 18 minus 3a. First things first is these are out of order. Before you factor, your terms need to start with the highest exponent and go down from there. Your number, the constant, the number without the letter, always goes at the end. So you just need to flip-flop those 2 terms to put them in the right order. So you have a squared, then the minus 3a, then the minus 18. So now it's set up. Trinomial again, it's just an a squared, so that's good news because it'll just be a and a. Not going to worry about my signs yet. I'm just going to write out all the ways to multiply to get 18. 18 and 1, 9 and 2, 6 and 3. I am multiplying to equal a negative. How do you do that? Negative and a positive. Which means I know when I'm going to find my pair, one of them is going to have to be negative and one of them is going to have to be positive. You can even go put those in. You can even put in the signs. And you can put the negative here and the positive here. Doesn't matter. What is going to matter are the numbers that you put with those signs. Okay? What pair are you going to use? You're trying to get negative 3. Which pair? You're going to be able to use 18 and 1 to get a negative 3, 9 and 2. Yeah, now we're talking. I just need to, I need to get my signs right because they're not going to be the same signs. One's going to be positive, one's going to be negative. How do I turn 6 and 3 into negative 3? Which one of these numbers needs to be the negative? The 6 does, right? Because negative 6 plus 3 gives you the negative 3 that you need. So now that you know what numbers go with which signs, just make sure that's the sign you put it with over here. So the 6 needs to come with the negative and the 3 needs to go with the positive. Number 4, v squared plus 4v minus 32. Everybody's in the right order. Still a good sign, right? There's just a 1 in front of my v squared, so it's going to be v and v. Let's write the ways to multiply to get 32. 32 and 1. Let's see, 16 and 2. And what's the last way? 8 and 4. This is a negative 32, which does tell me I'm going to have to use a positive and a negative, right? Because if I'm multiplying to equal negative anything, I got to have different signs. What's my middle number? Positive 4. Which pair are you going to use? Don't worry about your signs yet. We'll do that in a minute. I'm going to use this pair. What kind of 4 do I need to end up with? Positive 4, which means who needs to be positive? Right. Because if you make the 8 negative and the 4 positive, you're going to end up at negative 4 instead of positive 4. So make sure you put your 8 with the positive and your 4 with the negative. Number 5. Four c squared minus 21c plus 5. So still a trinomial, but this time it's not just c squared. This is a longer method because, now don't write this down. If you were going to factor this, how are you going to get 4c squared? Let's see, I can do 4c times c. Or, what's another way to get 4c squared? 2c times 2c. Which one are you going to do? You could go and try and then multiply to get 5. You don't know where you're going to put your 5 there and your 1 there, or your 1 there and your 5 there. You could do, it's called the trial and error method, but you'd have to FOIL all your answers until you found the one that got you back to here. I don't want to mess with all that. I want to do a problem, and if I do the correct steps, I want it to give me the correct answer. So I have a different method to use. And you may have done it in foundations, actually. This right here, I'm going to multiply times that outside number. So positive 4 times positive 5 is positive 20. I'll make a little chart. So now, just like on the last problems, I'm not going to use this number to find what multiplies. I'm going to use this new number. Ways to multiply to get 20. 20 times 1, 10 times 2, or 5 times 4. Still have to add to the middle. Negative 21. Don't worry about your signs yet. Which pair do you think you should be looking at? Right, that's not going to give me any kind of 21. That's not going to give me any kind of 21. What kind of 21 do I need? I have to multiply to equal positive 20. How do you multiply to equal positive? What are the two different kinds of ways? That, or what else? I'm going to equal negative 21. Which one of these do I need to put the signs as? Right, that's going to add to negative 21, but still multiply to positive 20. So that's what I'm going to do here. Negative 20 and negative 1. Just hang with me. I'm going to make two fractions. I'm going to put this number, don't even worry about the c squared, just the coefficient with a c under both of these. If those fractions reduce them. Does negative 20 over 4 reduce? Does negative 20 divide by 4? Yeah, what does it end up being? Negative 5 over 1. Does negative 1/4 reduce? No, right? That's already in simplest form. That's where your factors are coming from. Now that I've reduced this, what's the denominator? What's the variable down here? C. What's up top? 4. C. What's up top? That's your answer. So it's kind of a roundabout way of getting there, but I don't have to just keep trying different methods. To be honest with you, if I saw that 4c squared there and I'm starting off with just a shot in the dark, I probably would have gone with 2c and 2c, which didn't end up being the case. It ended up being the 4c times the c method. All right, 4 more. The last 4 are going to give us a rational expression and ask us to simplify it like number 6, 3x minus 24 over 3x plus 24. If I'm going to write this in its simplest form, it's not just a regular fraction, of course, right? It's got 2 terms in the top and the bottom. Before I can do any kind of reducing or simplifying, the top and the bottom both have to be in their factored form. So just look at the top only. There's only 2 terms. So the first thing I'm going to look for is something in common. What goes into 3 and to 24? What goes into them? 3 does. 3 goes into both of them. So let's pull out the 3. Put in parentheses what is left. If I pulled the 3 out of both of these, if I pulled the 3 out of this first term, what's left? Minus 24 divided by 3 is 8. So there's the top in its factored form. Now you have to do the same thing in the bottom. So again, 3 goes into both of those. So pull out the 3. This time, what's going to be left? So pull that 3 out. What's left here? X, good. Plus 24 over 3 is 8. Once you do the factoring, then you can do the simplifying, or what a lot of people will just call it canceling. If one of your factors is the same in the top and the bottom, they can just cancel each other. So those 3's cancel. So what's left in the top? X minus 8, and in the bottom, X plus 8. So that right there is your answer. Here's the difference between what cancels and what doesn't. If you are going to cancel, you have to be a factor. You have to be multiplied with something, not added or subtracted to something. That's why these 3's will cancel, because they are factors. They're multiplied with something. That's why these X's do not cancel. These X's are not factors. They're not multiplied with something. They are added or subtracted to something. So that's why that can't go any farther. Number 7. So it says simplify by removing factors of 1. We just need to simplify by factoring. Okay. So you got to factor. Always factor first. Then cancel. We're going to factor, then cancel. So let's look. Again, only 2 terms. So it's not a trinomial. I look for something in common, but there isn't anything in common with those terms. But look at those terms. Remember the other option. When you have 2 terms, and there's not anything in common, check to see if that's a difference of squares. To be able to factor its difference of squares. What can you use to multiply to get p squared? The same thing twice. P and p. Is there a number that you can use the same thing twice to get 64? 8 and 8. So that is a difference of squares. They're both perfect squares. So the way those factor, just like you said, p and p to get p squared. I'm going to use 8 and 8 to get 64. Here's the good thing. I don't even have to worry about the signs. When you are factoring difference of squares, you always end up with 1 positive and 1 negative. Now do the bottom. This one is a trinomial, like all those first problems in this section were. It's a good kind, right? It's not the long method. The long method is if there's a number in front of that p squared. If there's not, there's only one way to get p squared, p and p. Got to multiply to get 64. 64 and 1. 32 and 2. 16 and 4. 8 and 8. What are you trying to get in the middle? Right. Looking at these numbers, am I going to be using a 64 and 1 to get negative 16? 32 and 2. Nope. Getting closer. That's still not going to give me negative 16, but I can use the 8 and 8. How do I make 8 and 8 add to negative 16? They're both going to need to be negative, aren't they? Which doesn't mess me up, because what's negative 8 times negative 8?
Oh, fine.
Right, so it's still positive 64, but yes, you are right. They add to negative 16. So I'm going to use negative 8 and negative 8. Factor, then what?
Cancel.
This p minus 8, since they're factors, if they're multiplied together, that means they're cancelable. So this p minus 8 cancels this one. So what are you left with? Plus 8, good, over p minus 8. Number 8. We're almost there, y'all. It's a long day, isn't it? Number 8, z squared minus 11z plus 24. Z squared plus 4z minus 21. Factor, then cancel. They're both trinomials, right? They both have the 3 terms. They're good ones though, right? Because they're just z squared. They're not that long method like number 5 was, or whatever number that was. So the good thing is they both start z, z. Multiply, get 24. 24 and 1. 12 and 2. 8 and 3. 6 and 4. What's my middle number? Negative 11. What pair are you going to use? You're going to use the 8 and 3 pair, right? That's what's going to give me an 11. I just need it to be negative 11, which just means they both need to be negative. That's how you get negative an 11 with an 8 and a 3. So a negative 8, negative 3. Same thing in the bottom. Z and Z. Let's write out the ways to multiply, get 21. 21 and 1. 7 and 3. What's my middle number? 4. Which pair am I going to use? I'm going to use the 7 and 3 pair. I need it to be positive 4. What am I, if I'm multiplying to equal a negative, that tells me for sure I'm going to have different signs. So I'm trying to end up at positive 4, which means which one of these of this pair needs to be positive to end up at positive 4. If you're going to end up, here's how you can tell always. This sign right here, if your signs are different, this sign right here kind of tells you what you need more of. If I'm going to end up at positive 4 and I'm looking at my pair, I'm going to need my big number to be the positive number if I'm going to end up positive, right? If this would have been negative 4, I would have needed my big number to be negative to end up negative. So let's see, what do I need? I need a positive 7 and a negative 3. Z minus 3's cancel. So what are you left with? Z minus 8 over Z plus 7. Now, when I say cancel, they're actually just turning into ones, right? Anything over itself is a 1, which is actually going to be important on this last problem. Last one. M minus B over 6B minus 6M. Oh, gosh. here's the good news. This right here, I can't do any factoring there, right? There's only two terms. Nothing's in common with them, right? One's an M, one's a B, absolutely nothing in common. And it's not a difference of squares. So I can't do anything at all with that. So that's just going to stay M minus B. But look at this one. This one has two terms. It's not a difference of squares, but this one, these do have something in common. 6. So pull out the 6. Put in parentheses what's left, which means pull out the 6. If I pull the 6 out of here, what's left? B. Minus, if I pull the 6 out of here, I'm left with M. Now, here's what is odd about this. What does this say? M minus B, which looks very similar to this, except this M is positive and this M is less and negative. This B is negative and that one's positive. So they're not the same. They're actually opposite of each other, right? One's positive M, negative B. One's negative M, positive B. So they don't cancel out and make a 1 like all the other ones have. They actually cancel out and make a negative 1 over 1. So, what's left in the top here? Negative 1. What's left in the bottom here? 6 and 1. If I multiply, it just leaves me with 6. So your answer would be negative 1, 6. Okay, so that's the last problem. I want to kind of go over this, why this makes a negative 1. M minus B over B minus M makes a negative 1. And here's why. Give me a number for M, any number in the world. 6. Give me a number for B, any number in the world. 5. Doesn't matter. You didn't just get lucky. It doesn't matter what number M and B are. Let's plug these in. Everywhere I see an M, I'm going to put a 6. So what would this end up being? 6 minus, what'd you say B was? 5. What'd you say B was?
5.
Minus, what'd you say M was? Work that out. What is 6 minus 5? What's 5 minus 6? What's 1 over negative 1? Negative 1. Doesn't matter what number you would have told me these were. You could have even made one of them negative or both of them negative. It doesn't matter. These, if they're the exact opposite of each other, that's why it cancels out and makes negative 1 over 1 instead of canceling out and making a 1. If they're exact opposites of each other, that's going to happen every time. It's going to end up being negative 1 instead of positive 1. Okay, so that's why that ended up being negative 1 over 6. Okay, okay. On Friday, we will do 8.5, but be on the lookout. Since it is long, we have got to get through it though. I'm going to send you a pre-recording. I will send it in an email. I'll put it in the content folder. I will put it as an announcement in Blackboard. Kind of like a pre-lesson that's going to go over the different topics that we're going to cover in 8.5. So that way on Friday, when we get into class, I can just start working problems. I'm going to assume that you have all already watched the pre-lesson, like what needs to happen before the actual lesson starts or the problems start. Okay. All right. I will see y'all Friday.